So for this optimization problem, we have a hotel revenue. The problem states that a 40-room hotel is fully occupied if 3,000 pesos is charged per day per room. For every X hundred peso increase in the daily rate, there are X units vacant. What rate will maximize the revenue of the hotel operation? Before we get into the calculus of the problem, let's first have an idea of what actually happens. So it says that if your hotel is fully occupied, that means all your 40 rooms are occupied, then the daily rate is 3,000 pesos. If 39 out of the 40 rooms are occupied, your daily rate increases by 100 pesos and that becomes 3,100 pesos and you have one vacant room. If 38 are fully occupied, you have two vacant rooms, then your daily rate is 3,200 pesos. And so on and so on. And we're looking for the daily rate that will maximize the revenue of the hotel operation. And we know that the revenue is just the total earnings from all the occupied rooms. So that will be just the daily rate times the number of rooms that are occupied. To set up the revenue function, we have the base daily rate, which is 3,000 pesos per room, plus every 100 peso increase for every X units vacant. So you have plus 100X. And your number of occupied rooms is equal to 40 minus X, because X is the number of units vacant. Simplifying your revenue function, you will get negative 100x squared plus 1000x plus 120,000. And since we want to maximize the revenue, we need to find the absolute maximum of the revenue function. In order to find the absolute maximum of the revenue function, we need to differentiate the function itself and find the critical points. Differentiating the function will give us a critical number at x is equal to 5. This means that when there are 5 vacant rooms, then the revenue is at the absolute maximum for this specific revenue function. Thus, the daily rate when there are 5 vacant rooms is 3,000 plus 100 times 5, which is 3,500 pesos.